So welcome to you all on this next BrIAS seminar. And it's a great pleasure to introduce to you Hannu Toivonen, if I pronounce it a bit correctly, thank you. So Hannu is really well known, extremely well known in the AI community. So it's a real honor to have him here. To summarize a bit the research Hannu is doing, on the one hand, you could say it's related to data mining. It's finding interesting patterns in data, but it goes actually way beyond that. There's also a link to computational creativity. So the people who are here of the AI lab know a bit about computational creativity, I assume, through our colleague Geraint Wiggins. But for those who don't know, so Geraint often describes it as typically in AI we get a problem and we want to solve the problem. We find a way to tackle the problem, while computational creativity is taking another angle. It's looking for interesting problems to solve, so it can actually discover open problems. So I don't know if Hannu is agreeing with that point of view. Maybe we can discuss this after the presentation. So it's actually a very interesting way to do AI, I would say. And maybe today you're very surprised by these large language models, because they also pretend they can do that. But this work is much older than this large language model. So I think it's also very interesting to have some history on this field. So as I said, Hannu is a real respected researcher. So he's member of the Finnish Academy of Science and Letters, and also the Finnish Academy of Technical Sciences. So all very showing the talent Hannu has. But I also want to mention that Hannu was elected as the International Frankie Chair. So this is a recognition, and so you have to be proposed by different universities to be able to get this Frankie chair. And in this case, the VUB was in the lead, I would say, but supported by UGent, KU Leuven, and the University of Antwerp. So concretely, this means that Hannu is not only a BrIAS fellow, but he will be able to stay longer in Belgium. So after this fellowship of BrIAS, Hannu will give some additional presentations and share all his insights also within this international Frankie Chair setting. But that will be communicated later on. So now I will give the floor to Hannu to explain this very interesting field of computational creativity.
Okay, thanks, Anne, for the kind words and the introduction, and good afternoon, everyone. It's nice that you are all here. Today, like Anne said, I'm going to talk about computational creativity. In the age of generative AI, creativity is all the time in the discussion, so no need to motivate why to talk about creativity and AI in the same presentation. Here's a sample of works that we've done, sort of things to display, more artistic work. We've done an audio play with the Finnish National Broadcasting Company. We've composed music with computers to be performed live. We've worked on rap generation, image generation, and so on. The motivations and goals for these works that I display here have varied a lot, but something almost all of them share is that they are not done just for the computer to do something that looks creative, but they are done in order to fulfill some human interests, maybe many of them in collaboration with artists, some to involve users, in interaction and help them get new experiences with the help of creative computers. So the topic today really is how to use AI to support human creativity, but I will do a detour via computational creativity and creative computers, talking a bit about that. And the motivation is here. Lubar, 20 years ago, suggested this classification for different ways in which computers can support human creativity. And starting from using computers as a nanny, where the computer manages the work, maybe schedules and deadlines and so on, all the way to having a computer as a colleague, metaphorically, where the computer, the software, could contribute new ideas for the human. So this is what we are interested in, and in the age of generative AI, it seems obvious this is something we should look at. How can computers, by being creative, then help humans with creative ideas? There are three terms that are closely related and maybe often get confused in the public discussion: generation of something, being creative, and art. So let me start by a brief discussion of how I see these three concepts. Generation, as in generative AI, is the technical ability, technical skill to produce something. Images, text, video, speech, whatever. It's an objective fact. We don't need to argue if LLMs generate text or not. They do. But then when we move on to creativity, that's a completely different thing. That's essentially a subjective experience that we have. We personally can feel that something is creative or not. And whether LLMs are creative or not is a matter of debate. Creativity, of course, is a very complex phenomenon. So asking if LLMs are creative or not is a stupid question. We should ask, I'm not going to ask it in this talk, but if I were to ask, I would ask in what respects they are creative, in what senses, in what kind of tasks, in what kind of dimensions. It's not like we could classify people that you are creative, you are not, you are not. It's we are all creative in different ways, different aspects. And then art is yet a different thing. Not everything that looks art isn't art. It's of course subjective as well, but it's also very much a cultural phenomenon. What kind of works are accepted as art? When we talk about fine arts, it's the museums, galleries who act as gatekeepers and get to sort of form the opinion of what's accepted as art. Now, creativity is subjective and it's also cultural, but still we try to get some hold of it in the computational context. The fact that it's subjective doesn't prevent us from trying to be more exact and accurate about what it is in the case of computers. And that's what we try to do in the field of computational creativity. Here you can see, just to drive the message further, here you can see 6 different pictures, and I'm not going to make you guess what's produced by whom, but you can ask yourself, which of these are creative? Which of these possibly are art? And the question is complicated. You are perfectly entitled to your opinions on what you like, what you think is creative, even what you think is art. But it's extremely difficult to tell, right? Because you don't know how they have been produced. Who made them? Why? How? That clearly has a big impact on the value that we assign to these artifacts. So here, the one in the middle, on top, you might remember from the talk by Guillaume some 6 weeks ago. That's a piece of art that was sold by Christie's for over $400,000 in 2018, a computer-generated image. Whether you think it's worth $400,000 or not is not so interesting, but the interesting thing is here that the next image produced by the very same program was not worth $400,000 anymore. So the value in these images is not in the image itself. In the case of the middle top image, it's very much in the process and in the concept of having made a picture that looks convincingly like a human-painted picture with a computer in 2018. It's not the value of the picture in itself. On the top row, the picture to the left, that's something that I've made with a Midjourney program after long days of work, so not just by pressing a button. The picture on the right, on the top, is a painting made by a human painter, Alvar Gulliksen, a well-known Finnish artist. He most likely used computers to sort of plan the image, but it's hand-painted in the end. And the images on the bottom row are all made by Midjourney without any work, just writing a prompt and taking the image that comes out. So after knowing these facts, your opinions on the value, creativity, artistry in these images have changed. So what we try to do is, in computational creativity, to look more into the computer programs to get some insight into why we might think that some process is more interesting or more creative than another one. Computational creativity is defined by Simon Colton and Geraint Wiggins as follows. It's the study of computational systems which, by taking on particular responsibilities, seem to be creative. So it's like the definition of AI, pretty much, but not exactly. AI is often defined as computer programs doing something that would be considered intelligent if done by a human. Here, and I have italics to emphasize this, we are looking for computer programs that take on particular responsibilities. So they are not just working by mechanistic rules, for instance. And to motivate this choice further, let me just give you a couple of examples of where things could be done to fool the audience. If you just look at the outcome and it looks great. The first one is, well, the metaphorical monkey typing randomly and then by chance, after a million years, producing a sonnet comparable to what Shakespeare wrote, by chance, by accident. Randomness and accidents are not creative in themselves. They are not the kind of responsibilities that we expect creative programs to have. Obviously, randomness or stochasticity has a major role in creativity, so I'm not saying that there should be no random components, but poor randomness is not interesting. We wouldn't place much value on something if it was a random thing. The second example is pre-programmed behavior. The metaphor here is from the movie Wizard of Oz, where it turns out that all the great magic is no magic at all. There's a man behind the curtain pulling levers to make things happen. This same thing has been done a lot in creative programs. There's a very clever programmer who implements the creative process into the program, but the program itself cannot be said to have any creative responsibility. So again, if the program is very mechanistic, we wouldn't call it too creative, even if the outputs are good. And then the third case is a copy or imitation of existing things. If my system were to produce, to create images but it would actually, behind the scenes, it would just take a random image from, or a suitable image from the web and present that as its production. It might seem very good if I hadn't seen the picture before, but again, we wouldn't attribute the program with any creative behavior. And this, of course, is a concern also with regard to generative AI, which is trained on large masses of images, poetry, texts, videos, whatever. And it can be difficult to judge or measure to which extent it's copying or adapting or imitating existing things, and to which extent there might be some new components that might be creative. We in the field of computational creativity are not the first ones to discuss and ponder on these topics. In human psychology, already from the 70s, there's work on providing some more structure onto creativity and how to view it. And one of the ideas is that when we are talking about creativity, we should be more specific. What are we talking about? Are we talking about the outcomes, say the images? That would be the products in this classification by McKinnon and Rhodes. Are we interested only in the outputs, the products, or are we interested also in the properties of the artists or programs, in our case, the producers, or in the processes they use to do something? Do we want to talk about the creativity of the program or only its outputs? So if we talk about human producers, or computational ones as well, we might consider properties such as imagination, skill, intent, maybe emotions in the case of humans, and so on. Processes are close to us as computer scientists, of course, what kind of algorithms, models we can use to produce some creative behavior. Then the fourth category, BrIAS, stands for the environment, which on one hand provides evaluations, judgments, and feedback on the results, who often might be the sort of parties who form their subjective opinion on if something is creative or not. But it also stands for the environmental effects on the creation, like the society, the culture, and how they affect what people or computers produce. So when we talk about creativity, it's good to nail down, are we talking of the creativity of one of these four things in particular, or in the case of computer programs, we can also add the programmer as one of the P's to be considered here. Often they need to be creative as well to produce a program that is creative in itself. Here's a list of possible characteristics that we could see if we can find in a computational producer, a computer program that generates something. So the producer level of the previous slide. We can ask if the system is aware of the artifacts it's producing. Might seem like a stupid thing to ask, but many programs simply generate something without ever looking at what they produce. So can they look at what they are doing and reflect on that? Can they maybe modify their products to be better suited for the task? We can ask if they are aware of how they are doing things. Can they look at their own internal processes? Can they possibly even adjust them to, again, succeed better? Are they aware of the goal? Why are they doing what they are doing? For what purpose? Can they maybe even adjust their own goals? Are they aware of all the environment? Maybe they collaborate with others. They should. A computer program that generates something in isolation is not very interesting, except academically. And also time. Are they aware of what's been done in the past? Can they learn from it? Can they plan for the future? And just for clarity, by awareness, I don't mean anything consciousness or anything like that, just in a technical sense of the program being able to look at some of these things and maybe do inference with them, but also possibly even modify something. Another example that I will use then in the rest of my talk comes from Geraint Wiggins, currently of VUB. He proposed in 2006 the so-called creative systems framework, and my version here will be brutally simplified, so sorry Geraint if you are watching. But for my purposes, the following is sufficient. So the framework consists of 3 key components. There are rules R, which define the conceptual space. So if we are producing images, then it would be the space of acceptable, so whatever the goal of the image generation is. If it's portraits, then the acceptable space would be pictures with faces on them. Then there's an evaluation function which assigns a value to each concept or artifact. And there's a method to search the universe, which is wider than just the acceptable space, much wider. So there's a method to search the universe informed by these 2 components, what's valid and what's good. Now, the nice thing here is this is a very abstract formulation. The nice thing is that makes it very generic, so you can apply it to different systems, different algorithms, and try to see how to describe it in terms of these components. It's also similar to how search is classically being used in AI. But with a major difference, but that in classic search, you have one function to optimize. There's one function that you try to maximize or minimize. Here instead, when you have 2 of them, you have the definition of what's valid and what's good. There will be tension between those because there might be something good that is not valid. And if your search algorithm runs into that area, then that might be that might spur some interesting creative action. That might make the system reconsider what's valid, what's relevant, and so on. I'm not going into that anymore. It's great work, but I'll use that in my work when I next finally change my focus more towards the title of my talk, which is expansion of human creativity. So in computational creativity, we mostly look at the creativity of the system, often with the motivation of actually helping in the end the users be more creative. And we do that by looking internally what the creative mechanisms in the system are. But now I'll switch the focus over to look at the creativity of the user instead of the system. And then this makes the approach applicable also to black box generative AI systems where we cannot really look inside. And my trick here is to use the creative system framework to do this work, looking at the user, not the system, the computational system. So diagrammatically, what I want to do, now I'll switch over to talk about writing. We have a person here and something I call the creativity horizon. So the gray area here in the image, the creativity horizon, tells what the user, the writer, is able to produce, to write. So text X is something he, she can produce, but text Y is outside of his or her abilities because whatever reasons he cannot imagine that or cannot write that well enough or whatever. And now the question then, according to the title of my talk, is how could we expand, could we use generative AI to expand the horizon so that something that was not in the reach of the person becomes reachable? And what I'm going to present here very briefly is an autoethnographic study I did. One of my hobbies is writing, creative writing. So I did this study with writing aphorisms. Aphorisms because they are, well, very short, you can try to produce many of them, and you can more easily use a large language model to help you. So that's what I did. Also, ethnography means that I studied myself doing that. So the questions I was considering is the subjective experience of the author, of the writer. So this is not something you can study with quantitative methods. It's something you need qualitative methods instead. So it's clear that I can produce texts by using LLM aphorisms that I couldn't produce otherwise. But the key questions are, do I feel I created them with the help of LLM? Do I feel I own them? Because if I don't feel ownership, or I don't feel I'm being creative, then it's not interesting. So the question is, could this happen? What I did, I'm not going into any details. I wrote a lot of these video, recorded the sessions, transcribed the... I was thinking aloud while doing it, so I transcribed that, analyzed, synthesized results. And like I said, I used concepts from computational creativity in the analysis. And here's what the situation looks like then from the point of view of analysis that is inspired by Wigin's creative systems framework. So here, the creativity horizon is the gray area again in the middle. And now with a liberal use of concepts by Wiggins, I can try to dissect that somehow, or the limits of that creativity horizon with these three components. And these are all subjective things. So first of all, on the right, my subjective view on what kind of texts are valid aphorisms. And okay, my subjective view, and just to make clear, there's a very crisp line, but obviously these things are very, very fuzzy, and it's not, I'm not implying there's clear-cut border for these things, but more like the conceptual thing, conceptual way of seeing this thing. So some texts I consider are valid aphorisms. Then some texts I consider are valuable, are good aphorisms, or good texts. And then my writing skills, bottom left, set another limit on what I can do. So I'm able to write bad aphorisms. I'm able to write bad text otherwise. I might be able to write some text that I like that are aphorisms or not. And now then, what I wanted to do is to sort of see if and how, with the help of large language models, I could be able to reach some of the spaces that I wasn't otherwise. So text A is an example of something where I'd like to go. That's an aphorism that I like, but I wouldn't have been able to produce it myself. Then there are other possibilities. With the help of LLM, I might be able to produce a text B, which is an aphorism. It's an aphorism I couldn't have written myself, but it's not a good one according to my taste. And then, of course, with the help of LLM, I might produce texts that are not aphorisms that I might like. Now, the main goal for me was to see if I can find things like text A here, aphorisms that I think are good. But really interesting thing, if it would happen, would be, of course, if my concept of what aphorisms are, or which aphorisms are good, is somehow modified, because being exposed to texts that I couldn't have produced myself might actually change my opinion. So what happened typically when writing aphorisms with the help of an LLM is that I would give a prompt, and then I would get a text that usually, almost always, looked like an aphorism. That's what I was usually asking for in the prompt, for an aphorism. But it would be a bad one according to my taste. something that I probably wouldn't have written. But then based on the aphorism that I got, then I might have an idea of how to maybe use that idea and would use a new prompt to arrive in a new one, and the next one, and the next one. And eventually when I would see that there's an idea that is good for an aphorism, but I just wasn't able to make the LLM write it for me, I would then take it and write an aphorism that I like myself. This is a very typical pattern in the data that I had. The LLM produces fluently aphorisms, but not ones that I like, but often, sometimes there are good ideas that I can take and then write an aphorism that I like that I would not have been able to write otherwise. Okay, at this point you should be asking, so what do the aphorisms look like? I quickly translated to, so I made this in Finnish, quickly translated to, so you can see some of the results. Autoethnography is a scientific selfie. Since I was doing this using the autoethnographic method, all these things got mixed in my mind, so I was also looking for aphorisms regarding the methodology I was using. And another one here, if I were creative, my aphorisms wouldn't be this blatant. This, well, maybe both of these, they are cynical, and there's a reason for that. What happened, let me go back. What happened here with the LLM-generated aphorisms that I didn't like were that they were always very positive, full of sunshine and extremely boring. And I got fed up with those. So then I turned towards darker ones, cynical ones. So in that sense, during the process, my sense of what I valued was maybe shifted a little bit because of the fact that the LLM was only exploring a tiny corner of the space of valid aphorisms, despite my attempts to write prompts to encourage it to go elsewhere. I didn't succeed in that. Unfortunately, it didn't expand my concept of what's valid or what's an aphorism. It was more like moving my preferences in the process towards a narrower area. Okay, so from this autoethnographic study, the observations were that LLM was useful for generating ideas, but not final aphorisms. So it expanded my skills, but with little or no effect on what I valued or what I thought was a valid aphorism. So the creative horizon can be expanded. I didn't go into details, but the examples I gave you and I produced were ones where I felt I was the author, I was being creative with the help of the LLM. There may be more interesting result, but not the topic of this talk, is a cognitive model for writing, AI-assisted writing, based on a previous cognitive model for writing without AI support, so a modification of that. A couple of open questions remain from this. The first thing I think is really interesting. So I showed you the diagram where, despite my best attempts, the LLM was not able to produce aphorisms I liked. There always was an effort by me in writing the final aphorism, but also driving the whole process. So there was considerable effort by me, and that, well, the effort spent on something is known to be related to the feel of ownership, and ownership is a major factor for the feel of creativity. So if I had succeeded in creating great aphorisms just with a simple prompt, maybe I would not have felt they are mine or that I'm not creative. Also, something that I did not try to look at all in this study was if it pays off to use LLMs. I spent hours and hours being frustrated trying to make them do something useful for me when they didn't. So, just to wrap up, here's again the picture I showed in the beginning with examples of the creative and more artistic things we've done in my research group. And like I said, many of these have been made for some human interaction or human experience, or to be used by artists in their work. So not just producing things because of the academic and scientific challenge of that, that's a good reason as well, but there's always, there are humans, people involved. And I showed you some of the conceptual theoretical tools from computational creativity that can be used to assess the programs, evaluate in what respect they might be creative. And I showed with the last study also how you might be able to apply some of these ideas for the study of not only computational systems, but also systems composed of computer programs and users. And of course, this work was not done by me, but by all my researchers and PhD students. And here are some of the key people involved in the work that I've touched on here. Thanks very much for your attention.
There are questions.
Good afternoon, Professor, and thank you for this presentation. You know, I'm writing also poetry, and I'm not able to describe really what happened when I'm writing it. You know, I think it could be the same process using LLM, you know, or a black box, because you know when a sentence is coming to me, am I really able to really understand what is happening to me? I'm not.
Yeah, that's a very interesting point, because we as humans are not aware of much of the creative processes that take part unconsciously. And I guess in the case of poetry, many other creative work, there's an unconscious component. If you look at literature on human creative processes, there usually are a number of phases, most of which actually are conscious. So there's first the preparation phase, where in your example case might include reading poetry, living life as a human being, learning a lot about different things, including emotions, not just technical poetry, and life and so on. Then there's the incubation phase, which is unconscious, and then as a result of the incubation phase, then some ideas pop up into our mind, into our conscious mind. And often we attach that moment with creativity. It's like the single aha moment. But actually, according to current research on cognitive science, most of it is conscious. So after you get this aha moment, maybe you have an idea for your poem or lines come out, then there is a lot of work usually on the refinement of that, working on the poem. I don't know how you do it, but depends on persons and the case, of course, but usually a lot of work go also into refinement of the thing. And the final result then is actually mostly result of conscious work with some unconscious component. And because we as humans cannot introspect this unconscious part, it may feel that creativity is something inherently human. And we might find it difficult for computers to be able to do that. Or if you believe in in deep neural networks, you might say that, okay, they work sufficiently similar to human neural systems, so why couldn't they do that as well?
I have a second question, if I may. You talked about how to expand the horizon, to expand the creativity with LLMs. But how can I, by example, set up a prompt? Or what kind of variables can I give to the prompt to expand this horizon if I'm not aware of the horizon that I can reach?
That's a very good question, because what I didn't make clear, but thanks for making it, is that the horizon is extremely vague and clear, and since I don't know what's beyond, I don't really know where the border is. I think the answer is that instead of, for instance, in my case, instead of trying to somehow instruct the LLM specifically to go outside my creativity horizon, I was simply asking it to do things I felt might be useful for me. For instance, in the form of, well, aphorisms are simple because they are short. In that case, I could ask it to write aphorisms. I would come up with weird topics, for instance, in the hope that it would then come up with something that I would not have thought of. But I don't think you don't need to be aware of where your horizon is.
Thank you for your talk. You mentioned at the beginning that the first, one of the first images you shown was sold for 400,000 because it was one of the first made with a AI method or computer method or something like that. And the second image made by that algorithm wasn't sold at the same price. So there was also the idea of having something made computationally more than the value of the piece itself. So what is the difference? When does it stop being computational creativity as a gimmick and computational creativity as an extension of creativity?
Right. I think that's exactly what many of us in the field of computational creativity are trying to work out. How to make the computer, what would be the features, characteristics, processes in a computer program that would allow it to be really creative. In the case of this example that was the picture that was sold for a high price, the novelty was really in the fact of selling a computer-generated image. Once that novelty was used, the next one was not novel anymore because, well, the picture was different, but it was not sold because of the image, but because of the concept. And right, so having these computer systems exhibit different ways of using why they are doing something, maybe changing their goals, being able to introspect their behavior, observe their own products and reconsider them, and so on, could be some of the ways towards programs that are more creative and don't just sort of do the same gimmick again. Questions regarding how to make a computer program creative is as complicated as asking how to make it intelligent. There's no single answer. Just like intelligence, creativity is a broad field with huge number of subfields and different ways of being creative. There's no secret sauce to creativity any more than there is for intelligence. That's what I believe, at least.
Thanks for the talk. So you use this you explained how you use this framework from computational creativity to actually study your own creative process. What I was slightly surprised by is that you didn't talk about sort of work that goes back decades on how from social science or from literary studies that studies how humans write novels, and how novels are, or literary text are constructed, and how they work. Can you comment on that? Is there a body of work in comparative literature, for instance, that is useful for the kind of research goals that you have, or is it just outdated and not relevant anymore?
There does not seem to be too much. So the work quoted here by Hayes from 1996, and he presented the worst version of his model before, so this is the updated version. This is a cognitive model in a true sense of cognitive model, based on research into cognition and writing. So based on hard data, you might say. That seems to be pretty much the only one that I was able to find. That was not exactly, let's say, not useful as such in this work here. But then what might be interesting, the statement here in parentheses, is that I made a suggestion on how to expand that model to include AI assistance in this model. Now, I don't dare to call it cognitive model because I don't have the facts and experimental data to support that. But I think that might be a useful way of seeing how people can use AI tools that assist them in writing, on which, by the way, there's a hugely increasing amount of research now coming out after LLMs came out. Also research on how to support human writers has been expanding a lot. Yeah.
Yeah, hi. I have a question. It's very open. It's about the relation or the bias that we might have on effort when being creative. You said that maybe it's very much related to ownership, but then I also feel that if we click a button and then the thing comes out too easily, then we see that there's no effort, so we don't value it. And I think that's also very Western culture, that we value things if we see that there's an effort. So do you think it's because we are somehow biased in considering this thing valuable, or is it really a part or has a play on it?
Good question, and I don't have a good answer. So I know there's literature on this relationship between effort and ownership, but I can't remember if it's done in a more global context or if it's only based on Western culture. So good point, but sorry, I cannot answer that.
No, thanks.
Thank you very much for the talk. Guilford described the creative process as a mix out of divergent and convergent thinking. And as I experienced it, working with large language models or generative networks helps a lot in this divergent thinking, but not that much in the convergent one. And I wonder if you would agree to that, or if you see any possibilities to also establish something at these models to put more constraints to it, and that could help.
Mm-hmm. Your observation, I share the observation. So my experience on creative writing and trying to use LLMs as tools, yes, exactly. My experience is that they can be very good for divergent thinking, so getting new ideas, but trying to produce something that I like, that like in the case of aphorisms, something like that I like, or in prose, something that has my style, is according to my taste, is extremely hard, if not impossible. So it seems easier to try to just get ideas with the help of LLMs, but then do the writing yourself. There's maybe one exception is maybe not so much for creative writing, but factual writing is, of course, where you can use LLMs to polish your text. But for creative writing, that's not maybe such a good idea. It depends on the writer, of course.
Thank you.
If there are no more questions, I would like to ask a bit a related question, but then more related to reasoning, for example. So do you think we can use the same framework? So I use a generative AI to, for example, propose me a proof. Maybe it's wrong, but gives me some inspiration. Maybe I don't understand all the steps that it is using, so can change the prompt maybe. So it's very similar to what you were proposing. So do you think the same framework could be used to evaluate that process?
Okay, reasoning is a tough question because the abilities of language models to reason are
but even
limited.
Beyond language models even, because now you framed it very much within language models. I could a theorem prover, and maybe the theorem prover is giving me a proof that I don't really understand because it's using certain steps that I don't know, or so more general.
Right. I think it might be useful to make a clear difference between tasks that are sort of open-ended, like you often have in let's say in the field of arts. There's no clear way of evaluating; it's all subjective. On the one hand, and then on the other hand, you have problems where you can exactly evaluate how good the proposed result is. So, for instance, creativity in problem solving might be a case in, I don't know, we have many researchers in robotics here, so maybe a robot could use problem solving, be creative in problem solving in case it can then somehow automatically test if the proposed solution is valid and safe and fills those criteria. So maybe for theorem proving the same, does it matter where the proof comes from if it can be proven that it's correct?
Yeah, then, I agree. But then maybe I can phrase it differently. A lawyer who has to make a case, and you would use an LLM then maybe, or something else, generative AI, and it would come up with a way to argue something, but then maybe you say, by some of these steps I don't feel comfortable, generate me something different. So can the same way of looking to the problem or the field be used also in those cases? Because there it's not so easy to evaluate. It's not like right or wrong.
Right.
And it's also reasoning somehow.
Yes. Yeah. When one evaluates a creative system, the first thing to sort of figure out is what's the goal. What is the system trying to do? What do you want to use it for? And from that derive the evaluation criteria on how well the system is working or how good the solutions are. So it can vary really, really widely. And I think in cases like that where you want to be factual, like in the court, then somebody has to check very carefully that the arguments are real and that they are valid, because as we know, you cannot trust LLMs there.
Yeah, of course you cannot trust them, but
and if you want to be creative in the first place, I'm not sure. Maybe in the sense that you could come up with an argument that you wouldn't come up by your own, but then you need to do some additional work to check that it's really valid.
Yep. Were there other questions? If not, I First, we thank Hannu for his great talk.
Thank you.
Okay, so welcome back for this second session of today. So it's again a great pleasure to introduce the speaker to you. So Mehrdad Asadi. Mehrdad is a postdoc in our lab. And he has been working on explainability, so he will, of course, tell about this topic himself. But what else can I say? The Mehrdad is doing a great job on the EU project PEER. So he's very active in managing 4 use cases. So the idea of the project is it's on sequential decision making. That's the specific setting, but it's also about how can we make AI algorithms in this sequential decision making setting that really fulfill the needs of people. So we want to co-create them with the users before they are actually made. So you can imagine that this is a challenging job to talk to 4 different fields with different needs and to manage this all and unify it in a single approach. But Mehrdad is doing this very well.
Thank you.
So yeah, I'm now looking forward to know more about, I guess, also your previous work. So the floor is yours.
Thank you very much for the kind introduction. So hello everyone and welcome back. Today I'm very glad to actually be present as a BrIAS fellow, and I hope you enjoy the talk. I will be mainly talking about how we actually need to also consider explainability as a component in the machine learning pipeline, or also the software development. So just to give a brief outline, I will be presenting about the classical software architecture and how usually the software architect should actually have different concerns when designing an architecture of the software. But especially nowadays, we are facing on machine learning and AI component as a part of these subsystems. And we need to also consider concerns related to XAI during the design. And we will be studying some of the techniques that are state-of-the-art for explainability. And the work that we have done so far, we will look at a unified platform. We call it a spatial platform, where we actually integrate all of the XAI and also different metrics for evaluating AI. And then we will look at some use cases and ongoing works that Anders mentioned. So in the classical software architecture, just to give a context to this talk, I would like to illustrate how classical software architecture is actually evolving. So if you remember from the past decades, so we usually had some software systems that components are interacting with each other. And the software architecture mainly was actually responsible for technology choice, database choice, and UI UX design. But as this software architecture is evolving, we have new components like machine learning models and also the AI algorithms that get fit data from this software subsystems and also take some optimization and decisions on behalf. But then new concerns like data quality and also model accuracy and privacy arises as part of the software architecture concerns. So as the architecture evolves, we have different stakeholders also involved in the project. But nowadays, as long as we are facing the challenges with opaque AI and also the transparency that is required for the AI and decision making, we have different stakeholders that I will be actually talking about in the few slides. So as you can see, even these machine learning models recently, for instance, federated learning, we have distributed clients that add more complexity to this architecture. And it's very important to study how data quality and diversity and distribution of data would affect the outcome of these systems, and how we can evaluate the resilience of the models that are generated. So most of the talks until now in the BrIAS seminars actually already shown this significant advances in the statistical machine learning in compared to the symbolic approach that we had so far in the past, which was actually rule-based and much more understandable by the users and also data scientists. But now as the deep learning and also deep neural networks actually make this advancement much more understandable or envisioned for the data scientists, it is very important to consider to study this complex relationship that usually these deep neural networks come up with. And that's why there is a need for XAI. So for instance, considering this highlights, for instance, how opaque decision making is now complex that requires more human in the loop understanding, and also how this black box AI actually affect the trust of the human users who are actually interacting with this decision making. So that's why this is very important to consider approaches like explainable AI to try to make the decision making more transparent for the users and try to show this relationship among the data that the models are trained on. And one of the important regulations, which is called General Data Protection Regulation, actually in 2016 highlights that the users has right to be provided with enough explanations and also meaningful information when they are actually facing such AI system. And that's why explanations or explainability is part of the systems nowadays, and that requires some efforts to make these explanations more meaningful for the users. And the user could be even a data scientist who is developing the method or developing the model, but also users or customers of some AI decision-making system. I will be trying to actually give a summary of recent works on XAI and how, for instance, the performance and explanations make a trade-off today. So, for instance, we have deep learning methods achieving very high performance actually results, but on the other hand, because of the complex relationship that they find usually in the data set, they are not explainable enough, or they have some complexity that is not understandable by the users. But on the other hand, we have different simple approach like linear regression methods that it's understandable because of the weights or also the proportional importance of the features that is easily understood by the users. So there is a trade-off that we need to think about when developing some AI methods based on the use case, based on the criticality of the use case. We can approach different models to also not only cover performance, but also consider the explainability and how explainable they are. XAI actually covers 4 different perspectives. I will be actually talking more about the 2 in the down, in the below of the actually, for instance, explain to improve. It actually allows identification of flaws during the development of the AI, or also explain to discover, for instance, how different relationships are found within the data. But also, it is actually used to explain and to build trust with the users, which is out of the scope of this study, but it is something that I will be presenting in the future if there is some opportunity. But for instance, we need to consider human readable justification for a decision to make the human to trust in the decision. And usually this is done by studying with the users, having questionnaires and asking users how they actually trust the system and the decision that is made. and also the right to explanations, which is about how the user would be able to change a certain decision, which we call it counterfactual, because counterfactual is one of the explanations that is very user-friendly, because the user would be able to change a certain decision of the AI or the system, and it is very valuable. But as I said, the main talk will be targeting the two. Information extraction and identification of the system flows. So this slide, actually, I want to emphasize different approach and different techniques for explainability. For instance, on the left, you see directly explainable models, which I just mentioned. For instance, the linear models, which are simple enough, or decision trees. But just to highlight that, for instance, decision trees are explainable on certain depths, because, for instance, there were many studies that as you actually have a complex relationship within the decision tree, it's not explainable at all. But those are models that we consider as directly explainable. And there are many post-hoc explainability methods, considering global explanations for the model, which actually try to globally explain certain models and the relation that is found. And also, some of the methods consider explaining a certain decision or one instance, which is, we call it as a local decision making or local explanation. And then the other approach are actually counterfactuals, trying to generate new instances based on some hypothesis that the user might have, trying to show a user how he or she might be able to change a decision of the system. For global explanations, usually the methods or the approach that the researchers has actually used so far are feature importance, showing what features play a critical role in certain decisions or the outcome. And also knowledge distillation, that, for instance, you have a deep neural network, you try to distill knowledge from that deep neural network, and then use a simpler model like decision trees to approximate the complex model. But still consider the trade-offs, and then the lack of performance in compared to the general or in compared to main complex model. And then also there are explanations for the local decisions. Then same as the one that I just tried to mention, they also consider local feature contributions towards some certain outcomes. But usually when you talk to AI people, they have concerns like that, what the explanation looks like. So depending on the data set that you are working on, or the use case, for instance, the explanations would be different. For instance, in the case of tabular data, usually the explanations show some values that shows the importance of the features of each record. Or in the case of images, they usually highlight the pixels that resulted in certain decisions. And also the text, this slide actually mainly is classification task. So that's why you can see the different classes that is classified. And then we show certain features that were important for this decision. But then just before the session, I tried to generate a nice prompt for to showcase how AI or explanations would be appear in the case of generative AI and ChatGPT. I just ask a question like, I'm a postdoc researcher, how to actually continue my career, and then there are some actually approach to take. But then when I asked the question, why did you give me this answer? For instance, the generative AI tried to give me some important feature in my question, highlighting why the question was based on. So it's not only the classification task, but also the sequential decisions, also the time series data that would be enabled to generate such explanations. But another question in XAI is, how should we evaluate it? There are two different approaches. One is actually based on the user and the user studies, usually we try to see how explanations are understandable by the user to solve some specific task or the performance that he show on the specific task. And also the satisfaction of the user, how the user is satisfied with the explanations. Can he actually make the decision on behalf of the AI overcoming the task? And also predicting the AI decision based on the explanations that we show. Or also the inherent metrics that we actually computationally evaluate, like fidelity, which actually measures how accurately the explanations reflects the true decision-making process. So it's very important that I will show in the next slide, for instance, in the case of LIME approach, how the explanations reflect the true process in the back end of the AI. And also stability, which evaluates how consistent the explanations are when given similar instances. So we need to actually consider the stability as a metric when generating the explanations, because similar instances should have similar feature importance and be same. And there are some other metrics that I would like to skip here, but there are references that you can actually look for it. But for the first method that I would like to introduce is actually local interpretable model agnostic methods, which is called LIME. LIME actually is a local fidelity method. In the locality of the instance, they try to approximate it as much as it can. So it's very similar to the original model output. And then it is simple and linear. So consider we have a deep neural network on the left. And actually, LIME consider this as an optimization problem, where actually on the instance that is need to be explained, they try to approximate it using a linear regression, which actually tries to minimize the loss between the linear model that is actually generated and the real model, which is actually F. And also a regularization term, which tries to keep the model as simple as it is. So it's kind of locally approximating the complex model. That's why it's called a local interpretable model. But just to highlight, one of the actually drawbacks of such approach is that it cannot recover complex relationships. It's just simple linear. So that's why some of the relationships which are complex and the feature interactions are not considered. And that's why now we have a new method called SHOP. It's based on a cooperative game theory approach, theoretically justified, and then it is able to generate both local explanations for a specific instance and also global explanations to actually have an overview over the complex model and how the features are important, and also it could be used for handling a complex relationship and also feature interactions. So actually, SHOP treat each feature as a player in a cooperative game, and then they try to model this prediction as a, for instance, a payoff could be considered as the prediction of the model for certain instance, and they try to distribute the payoff or the prediction score to different features. So kind of fairly distributing the features among the, distributing the score among the features. So here, for instance, F is the set of all features, and then we have the subset of features excluding I. which is S, and then for instance the function fs is the model prediction using only the feature S and also in combination with the I. So trying to actually consider every combination of the features. That's why SHOP is one of the complex methods, requires much more computation than LIME, but it's still having nice results in case of fair distribution of a score among the features. SHOP uses different plots for conveying this information. For instance, force plot, waterfall plot, and also Bayes-Warm plot. This is actually an example of the Bayes-Warm plot for showing the feature importance, the global feature importance of the model using SHOP values. Actually, this is an example for loan agreement prediction, I guess. And then it shows how different features play a role in some certain prediction or the decision of the model. And then we have layer-wise relevance propagation, or we call it LRP. Actually, this is a top-to-bottom approach. What I mean is that, for instance, in the case of two previous approaches, like SHOP and LIME, usually we try to compute the feature importance for a specific features at the runtime. But here, once we make a decision, we propagate back the weights, for instance, in the case of neural networks, to the features which were actually, or the neurons that were important. And then that's why it's called top to bottom approach. And then also is mainly designed for interpreting neural networks and follows the conversation principle, meaning that the total relevance of the output is propagated fairly to the features layer by layer. That's why actually propagating the importance back to the feature set or pixels. For instance, in the case of images, we can see that the classification task, they try to highlight the features which were mostly important for certain predictions. And actually, the equation also compute the relevance of each layer or neuron to be considered as important in the case of LRP method. And one highlight is that it directly requires access to the model structures. So this is not model agnostic. So for instance, in the case of LIME SHOP, you can apply that to any model, but here the model is specific and you should consider having access to the model structure. And then counterfactual explanations. So usually counterfactual explanations describe a causal situation. For example, I have an example here, but okay. If I hadn't taken a sip of this hot coffee, I wouldn't have burned my tongue, for instance. It's a kind of explanation, causal relationship, and then a counterfactual could be I didn't drink the coffee at all. So that's kind of another hypothesis that a user might be interested in, to know what could be changed to result in different outcome. But it's important, in the case of counterfactuals, there are some metrics and criteria that we need to consider. For example, a counterfactual instance produces the predefined predictions as closely as possible. So usually a user defined a certain interested outcome for the AI decision, and then we try to generate counterfactual based on that predefined outcome. And it's very important to actually generate an instance that could be closely to the predefined prediction. And a counterfactual should be similar as possible to the instance. We cannot change a lot the features to generate a counterfactual. I mean, it's kind of optimization problem that we need to consider changing few amount of features and also by some certain minimum value, not to change much. So kind of against the counterfactual explanations. And also it should be possible in the real world that counterfactual instance should have some values, some certain values that are logic, and following some principles in the real world. For instance, one of the methods that was actually proposed by actually Wachter, the first term is actually considering the differences between the predefined prediction and also the model prediction of the new instance, which we call it counterfactual, and then the second term is actually a distance measure, how similar those instances are. Kind of, we need to optimize it based on the difference between the values of the features. And then we try to optimize this loss to generate the counterfactual for the user. And one of the drawbacks of this approach is that actually they just consider the two first criteria, which was the distance of the counterfactual, and also the other one, which was the distance between the two examples that we need to consider. And they do not consider, for instance, unrealistic feature contributions or feature differences. And then to overcome that problem, in 2020, a multi-objective optimization problem based on these criteria was actually formulated to consider all of the four criteria that I just mentioned in the few slides before. So they actually try to use the multi-objective optimization approach and also genetic algorithm to generate such a counterfactual. And to the best of our knowledge, at the time that we were developing a uniform, trustworthy platform that a user could actually upload their model or also use the platform to apply machine learning models, the different actually explainability approaches were somehow isolated and they were not integrated in single platform. So what we have done so far, we tried to generate or create a novel component, which actually we call it trustworthy augmentation, that not only consider some XAI methods to be applicable for some use cases, but also there are different metrics such as fairness and trustworthiness and resilience that could be implemented in the platform, so a user could easily access this through some APIs and generate explanations to increase its trustworthiness. Both a user could be a customer accessing some model, or also a user who is data scientist trying to generate a model. So this is a kind of our recent works on the defining a novel architecture and also implementation of this. So for instance, we use the microservice architecture approach, where we actually have defined different XAI methods as kind of microservice and totally independent of each other. And also different metrics such as fairness that are integrated in a single platform and could be accessed by just some API gateway. For instance, in the case of us, we just implemented that using Kong, which is one of the well-known and lightweight API gateways to let the users access all of the services at once. So some of the use cases and results in the case of adversarial machine learning. So we used this implementation to apply that for different use cases. For instance, in the case of medical electronic calling application, actually it's a kind of mobile application that uses accelerated data of the smartphones to detect the falling of the elderly people. And we use the dataset such as Unimip Sharp dataset, actually representing different activities that a user might have in a home. And some of them, for instance, 8 classes, if I'm recalling correctly are considered as a fouling activity. And we try to use actually adversarial attacks to evaluate how XAI could be helpful for evaluating this type of attacks and understanding the behavior of the model in case of attack severity. So the two well-known attacks we have performed for this adversarial machine learning was actually black box attacker for this scenario, where the user do not have any knowledge of the model or the logic, but just the training data. So they can actually try to, what we call it as a poisoning attack. They can try to lower the quality of the data just using perturbational attack or just changing the features, values, or also label flipping attack could be actually changing an instance labels to something that is not correct in the real world. So this type of attack was performed to see how, for instance, in the case of shop value could be useful enough for detecting the severity of the attack and poisoning attack. So therefore, actually, we have tried different AI or machine learning approaches to see which one actually could be best as a baseline. So as you can see, for instance, the deep neural network is the one that we that performed the best on our data set. And as we increase the level of poisoning attack randomly by some percentage, we can obviously see how actually model resulted in a bad performance in the case of test. But then the novelty of this approach is actually how we can quantify these poisoning attacks using Shapley values that I just described in the slides. So basically, as the we have considered a metric called average Shapley distance. At the test phase, we try to see how model actually globally is explained by the Shapley values. And then once we do some poisoning attack, these Shapley values shows a significant change in the feature importance, which we can call it as a quantification for detecting the attacks. But also, one of the open question is actually we have different type of attacks. We still need to understand how these methods are useful for detecting a specific type of attack and not just the severity of the attacks. And then another use case is actually network activity classification. So this is actually a work that we have done with some colleagues. The data was provided by a company called WithSecure. They actually, as internet service provider, trying to understand the user behavior. So here, the goal is actually to identify a type of activity that is user has actually during browsing the internet, whether is it just streaming or is actually some other activity. So basically, the data set was a real data set that we have received from our colleagues. And then we have different adversarial model here. The difference is actually the model is accessible by the attacker. So for instance, it's very common in the people where actually there is some intruders inside the organizations actually having complete knowledge of the model, and they can perform such attack. And also we have different attacks such as evasion attack, actually called fast gradient sign method. This is one of the attacks that we performed so far. We try to actually add noise to the data based on the gradients of the model. And also the two label flipping and label swapping attacks that we just considered in the previous use case. So kind of targeted attacks. Again, the same results that shows how Shapley value could be considered as a detection mechanism. So for instance, in the figure on top left, you can see that the classification task actually considers how features are important for this type of model without poisoning or benign data when the model is trained on the benign data. And then once we try to do the evasion attack on the data, we can see that the order of the features, which were important for the benign model, completely changed. And then it shows the applicability of the SHOP values for detecting the attacks of evasion. And then the two-figure below actually shows, we tried to introduce two novel metrics such as impact and complexity. Actually, impact is how the model was how the model misclassified the Poisson data, and then the complexity is actually how complex was generating the instances for the to actually confuse the model. So basically showing the effect of a Poisson attack on these two metrics. As the Poisson attack increases, the complexity and also impact increases linearly. And just to highlight also some of the works that we have done so far, because the theme of the actually BrIAS was also sustainability. So it's also important to consider computational overhead and explainability and scalability for the metrics that we have developed so far. So we also performed some simple experiment to see how many actually concurrent users can access to the services that we have developed, and actually how the scalability looks like. For instance, in the case of the left, so we can see that once we increase the number of users accessing the metrics concurrently, the response time is actually not very increasing suddenly, so it's actually stable enough. But then the other two methods like SHOP and LIME, which are actually well-known methods for XAI, for both tabular data and also the images, we can see that at a certain amount of time, the computation time increases to up to 8 minutes for single image. But then still, it's some thing that we are now doing much more experiments to see what happens if a certain instance is asked for different services to be explained at the same time. So to have more insight about single instances. And then what we are now working on to actually apply the same methods for reinforcement learning setup. So actually in the reinforcement learning setup, we have some environments and the agents taking some actions and trying to optimize some policy based on some reward function or goal. So what my colleague has done, for instance, in the case of the first simplifying the agents model, trying to, for instance, distill a knowledge from the deep neural network, that is deep reinforcement learning actually network, but then trying to create a data set and then generate a simpler model like random forest or the decision trees. But the problem is actually the agent is not able to explain a single instance. It's just globally explaining how the agent behaves. But then different approach for explainability in the case of reinforcement learning is actually how we can communicate the preferences and the rewards of the agents to the human based on the user preferences. But the thing that I'm working on it now is actually how should we explain an agent decisions based on long-term consequences, which actually would be interesting because it would be influenced by both the dynamics of the environment and also the actions that the agent takes. So it's very important to understand how we actually can generate explanations that could be answer some questions. For instance, what is likely to happen from the state, some specific state with the current policy. So showing the user a long-term behavior of the agents and the outcome of the policy. So now, yeah, that's what we have done so far and what we are now working in currently. So thanks for this opportunity, and if there is any question, I'm happy to hear that.
Questions?
Thank you for the presentation. I have a small question. So in one of the slides, we had like 4 plots. A bit before, there was, and you were showing the poisoning increasing.
This one?
No, before again. I'm sorry. Yeah, this one.
Yeah.
How comes on the bottom left, like the yellow line increases with the poisoning? How can that be? What is
because once you actually, that's a good question, because at some point we have observed that when you actually increase the poisoning level up to certain amount, like more than half of the data set, then the distribution of the data completely changes. Then that's why sometimes the performance also changes based on the training set that we have actually imported new data that is fake. That's why.
Okay, thanks.
Hi, thanks. Sorry, it's great to see some attention to explainable AI in this seminar series. So in my field, there's a lot of interest and also a little bit of gloom under the heading the disagreement problem in explainable AI. And so the finding there is that basically with many of those explainers that you also, many of which you explained to us today, have very nice theoretical motivations, but maybe those theoretical motivations of assumptions are sometimes violated, and in practice they produce extremely different explanations. So if you apply SHAP, integrated gradients, and all the other ones you mentioned, if you apply them, especially in the LLM world, for instance, you get radically different explanations. So have you run into that disagreement problem yourself, and you have ideas of how to move forward?
I think that's a nice point, but one of the highlights that I made in the beginning, most of these methods were evaluated computationally, and we really need to design a questionnaire that we can do a user study with the users to see which one actually would be meaningful enough for the users. That's something is actually out of the scope of these presentations, but what we are now doing within the project, we actually develop different XAI methods, but before doing that computational work, we try to simulate the behavior of the explanations and to study with the users. So that's something that I would say I agree, but it's a still open question within the community.
I also have a question about the reinforcement learning slide you had at the end.
Sorry, can you repeat?
The reinforcement learning slide that you had at the end.
Yeah.
What do you think would be a good approach for explainable RL? You discussed a few different ones, like either explaining a local decision or the whole model. What do you think is a good approach for explainable RL?
I would say that one of the actually methods that would be much more reasonable for RL setup, because we have an agent taking sequential decision making, is actually contrastive explanations or counterfactuals. And also one of the points is that you should consider generating the counterfactuals that explains how early changing the decision would result in different outcome, because some of counterfactuals try to generate different different policy, but actually it's not the case that would be understandable for the user. I would consider generating counterfactual based on the specific state that you have, showing how the change into the state would result in different actions, step by step wise.
So that would be the agent building its own model of the environment and estimating the next states depending on the action or something
Yeah.
like this?
Yeah, something like that. Yeah.
Thank you.
And also trying to align with the mental model of the human and the users, because sometimes the difference between the mental models actually result in misunderstanding between the communication between the user and AI. And first we need to see if the models of the agent aligns with the mental model of the user, and then that requires also some effort, and then trying to explain based on this alignment.
Thank you.
Yeah.
Okay, no more questions. Then let's thank our speaker again.